Good morning, good afternoon, everyone. I'm Qazi Ahmed. I'm the product manager for PowerPro. PowerPro is Siemens EDA's low power platform for RTL power estimation, gate level power estimation, and power optimization. In today's session, I'll briefly cover some aspects of power, of why it's important today. I'll be covering the early power checking stuff inside PowerPro that lets users do power audit and power lint. We'll also cover power analysis and then power analysis done through emulation. I will also cover RTL power optimization on how to reduce power and achieve energy efficient low power designs, followed by a few examples of how customers have succeeded with PowerPro. So power is everywhere. If you look at the different vertical markets today, power traditionally used to be a concern with mobile phones and handheld devices, but that's not the case now. Power is the #1 concern simply in almost all vertical markets. So you can look at data centers or AI and edge devices, networking companies, even automotive. Power has become very, very important and has taken a center stage in the design flow. Power can also cause other problems, for example, respins. So in a survey conducted by Wilson Research and Siemens in 2020, it was found that power was the #3 reason for chip respins. Power can cause other problems. For example, power can, impose limits on your performance. It can reduce the battery life of your devices, and it can result in high thermal dissipation, which can drive your packaging costs higher. So having talked about why power is so important, why it's taking center stage, let's check out where is power impacted the most. So in a typical design cycle, power is most significantly impacted at the early RTL stage or the architectural stage. So this is the stage where you will have the most amount of power savings when you make changes to save power. So trying different microarchitectures, for example, checking out how your power should be, planned, what kind of voltages and corners would use. Then, of course, using different kinds of high performance and low performance cores, etc. Once you take the architectural decisions, you might do some microarchitectural changes in your RTL. So that's what you do in your early RTL. To kind of change the RTL to save more power, not waste power, and to become more energy efficient. And as you go ahead and your design matures, the opportunity to save power reduces significantly. So as you go towards the gate and then towards implementation, there is minimal impact on power that can be achieved. The other thing on handling power early in the design cycle is that any changes you want to make are easier to fix because you're changing RTL or you're making decisions on the architecture or you're comparing different architectures. These things are easier to fix early in the design cycle. You can also evaluate the change and the impact of that change in terms of, for example, power estimation when you're doing RTL because RTL simulation is faster. Now, in order to do power right from a very early, stage of your RTL design, architectural, algorithmic maybe, and right until the time when you have your RTL and early gate implementations, this is where, as we mentioned, the maximum amount of power savings can be achieved. So that means there have to be, tools that can support early power checking, giving out you the power problems earlier and sooner when you just started coding your RTL, making your modules and IPs and blocks. And then as you move in the cycle and your IPs get bigger, they get mature, you have the better stimulus to measure power. So, power qualified vectors, for example, you want to use them to perform power optimizations, for example, insert clock gating, or maybe gate your memories, or look at different aspects of where power is wasted and try to fix that. And then as you go into the subsystem, when your IPs start getting staged and you have a bigger design or an SOC, some of it RTL, maybe some of it gate, you want to do power estimation for the entire subsystem or the SOC to make sure you're within your power budgets. So PowerPro has early power checking to do your early RTL power audit and lint and lead you to the power problems while you're developing your RTL. This is the kind of thing that helps you develop low power code while you're coding. Then when you go to the RTL power analysis and optimization, so this is exactly where PowerPro will tell you what is the current power of your design. Where do you think, where are the portions where you can actually optimize power, find the culprits, fix the power problems, reduce the power, and then finally, when you go to system level, you can measure the power to see if you're in the ballpark. So you can do full cycle tracking of power and establish regressions around it to make sure your power is within your budgets and you're not wasting any power. So let's start with early power checking, as I just mentioned. So early power checking in PowerPro is performed without the need for vectors. So early RTL analysis can be performed with RTL only. You might not have vectors, or you might have small test benches. You're still developing your RTL. What PowerPro does, it performs structural checking of your RTL to find culprits in your design that can lead to wasted power. So PowerPro reports various metrics that point out that the design has been poorly implemented from the perspective of power. And for that, we have multiple metrics in the design. For example, it will tell you the coverage of the different kinds of gating that you have in the design. Are your memories gated? Do you have macros that have no gating conditions? What about your memory inputs? For example, your mux inputs, or if you have registers in your design, lots of them, of course, they have to have an if condition so that they can be combinationally enabled. It also checks on some of the design structures, for example, CGICs. So you might have constant CGICs that are not contributing to any power savings, or functionally or structurally redundant CGICs that may again be structurally redundant, consuming power of its own, and not really, not really contributing to any power savings. So these kinds of early checking and lint related power lint related checks help you find the problems earlier in your RTL while you're doing it, and becomes a very good indicator, or let's say a key performance indicator of your RTL coding quality from the perspective of power. Then there's the second kind, which is also kind of, power audit that you do on early vectors or basic vectors. So this one requires vectors. So this is like what we call microarchitectural or combinational redundancies. So in any, switching activity that's propagated through your logic, some of the toggles will be functionally valid. Some of the toggles will actually are like kind of redundant. They're functionally not needed. For example, if you have a mux, if one of the inputs is selected, the toggles happening on the other input are completely redundant. So that's an example of redundant toggles. Now, these checks, with the help of stimulus that you have, basic set of vectors, helps you identify if you have wasted toggles in the design. It tells you these things around, like your registers, if your clock is toggling, but your data is stable, or your data is stable, but your clock is toggling. Redundant memories for their address and data ports. It also tells you the similar things around memories, like the memory is stable, it's not really, nothing has been written into it, etc. And then there are other transformations that are microarchitectural in nature. For example, converting shift registers into circular buffers might actually help you save power. You can easily debug these through reports, through GUI, and to cross-probing between RTL and schematic, etc., to fix these problems after we root cause them. Now, on the power analysis side, once you have identified some basic problems, low-hanging fruits, you're developing your RTL, you have fixed a lot of those, now you have some blocks in shape, you want to do power analysis, you want to measure the power. So PowerPro has a comprehensive portfolio of different kinds of power analysis flows. So it supports RTL to gate, IP to SOC. So for RTL and gate level power estimation, we guarantee that your RTL power estimates would be within 15% of layout. So if you're doing power estimation for RTL, early RTL, late state RTL, usually all your power numbers compared against layout or sign-off level power numbers, PowerPro's RTL power numbers will be within 15%. Usually they're better, even sub 10%, but 15% is what we really say. And then for the gate level, of course, it's like within 2 to 3%. For the flows, PowerPro supports both average and time-based power. And when we say time-based power, it's cycle accurate, which means we compute the energy cycle by cycle and divide it by the period of that cycle. So you get the power for exactly that cycle. So this is cycle accurate power. We support a variety of input switching activity formats. The QWave is Guesta, FSDB, and SAVE. And STW is what comes from the emulator. We're talking about Veloce, and we'll talk more about that. It also supports a comprehensive, debug and report, summary, hierarchical reports, power by categories and components, even energy numbers by category and component. You can look at power by clock domain, etc. The reason PowerPro is able to do RTL power estimation accurately and still fast is because under the hood, it runs Oasis synthesis to create a very close representation of an actual netlist, followed by PSM, which is a recon engine that can kind of reconstruct some of the switching activity on the combinational side and gives you really accurate power. And to get the time to power, you also have a multi-CPU architecture underneath. On the system level power or SOC level, generally emulators are involved. So for handling a large SOC, and doing that with software, putting the OS, having all your software installed and your software running with the hardware-software co-verification, that gives you the most accurate numbers. And you have standard, switching activity profiles, for example, Angry Birds, Drystone, car chase, etc. So you want to try to generate power for these workloads. Now, what emulation does is that it gives you allows you to do hardware and software co-validation and then do power that is software driven as well. In PowerPro, it's tightly integrated with Veloce, and we have a unique solution to capacity, which is called design partitioning. So PowerPro allows you to partition the design into multiple chunks, and it computes power for those chunks on separate processes or CPUs. And then, of course, you can allocate more CPUs for the speed up of the traces that you give. So what happens is there's a partitioning in space and time that allows PowerPro to take in the largest possible designs possible. And also for extremely long traces, it will compute power. We can claim very clearly that we support the maximum capacity and the best turnaround time when it comes to system level power. And what happens is you run Veloce simulation, and if you identify your areas of interest, for example, you want to find out areas of peak or power, or IR drop, potential IR drop kind of stuff, you can isolate those areas using Veloce and then run power analysis on that part or power optimization on those portions which you think are the regions of interest. Finally, PowerPro for power reduction has power optimization. So if you're doing power estimation, you know what your power is, but then what? Of course, if it's higher, you want to reduce it, and you want to find out where you're wasting power and what's the best way to reduce this power. So PowerPro has two versions of power optimization. They're called guided and automatic. Guided power optimization is like, we suggest you the changes, you make the changes and factor them into your RTL, you verify them, and you're good. Automatic power optimization is unique. Only PowerPro has something called automatic power optimization, in which case PowerPro also writes out the automatically optimized RTL, writes out a script for a formal tool that's tightly integrated with PowerPro. It's called SelectPro, and then formally verifies that the machine-generated RTL, which is power optimized, versus your hand-coded original RTL are functionally the same. PowerPro is the #1 tool in power optimization today. We offer the highest amount of power savings because of our deep sequential analysis engine. and we kind of, give you all kinds of power saving opportunities for clock gating and for memory gating, etc. So it has a simple interface. Even if you want to go to the GUI and you're using the guided methodology, for example, and you want to save some power, you have some suggestions coming in from the tool. You can cross probe, you can root cause, you can see what are the drivers, and you will figure out how to fix that in your RTL. Now, the clock gating optimizations in PowerPro are essentially the best, industry leading. And what it does is, for a list of flops, it will find the best enable condition that will save you the most amount of power. And then it will also tell you what is the exact expression you need to implement in RTL. Some of those expressions can simply be copy pasted. So you want to put that expression, in your if condition, and that will implement your clock gating. Now, when it comes to the automatic part, the automatic flow is a push button flow. So the same thing you would do manually, for example, that PowerPro reports a suggestion and says, this is what you can implement, and this is the amount of power you will save if you implement that. PowerPro's automatic flow can simply generate that low power RTL. With that inserted, it will keep and maintain all the indentation, and then it adds this extra / PowerPro CG comment, so that you know that this is inserted by PowerPro. So it will maintain your original RTL as is. It will maintain its indentation. It's easy to figure out where did PowerPro do something or anything, which increases your verification productivity because this is machine-generated RTL. You can simply verify it using a sequential LEC tool, and we offer Select Pro with the automatic flow, which formally verifies that the machine-generated RTL and the original RTL are same. And that therefore you don't have to add extra efforts to verify and do things on the testbed side. Now, lots of customers have succeeded with PowerPro. We'll just kind of talk about a couple of the big ones. ARM is a PowerPro user. And ARM, they live for power. I mean, power is what they do for a living. We can say that. So ARM has introduced and integrated PowerPro in its low power methodology. So what ARM does is that for all IP blocks that they have, before they check in their RTL, they run PowerPro. So they will run power estimation, they'll run power optimization. They run power estimation to figure out what was their power of the last revision and what is the power for the current revision, and they will plot the energy efficiency and the power efficiency of their RTL as they progress in developing that RTL. At the same time, on a weekly basis, they will also run PowerPro's power optimization to make sure, is there any power left on the table that could have been saved? So they ensure that no power is left on the table. And by being that strict and ensuring that PowerPro is regularly used as part of their power regressions, they regularly test their RTL for any power-related problems, and then they compare that against a sign-offs. In their case, it's PTPX. So they usually find that the power numbers are within like 4% to 14%, not beyond that, and they're checking their power for low. They're checking their RTL for low power and saving loads of power, being very, very power efficient. They use it across the board. It's the plan of record, for them. It's being used for CPUs, for GPUs, interconnect subsystems, display ports, whatever. And it's part of their flow. So there's a white paper that ARM did with us, and the link is here. You can download this white paper to understand what is ARM's methodology with PowerPro and how have they been able to successfully, develop low power RTL. The other big one is Samsung. So Samsung is a mobile company, okay? They do different things, but principally it's the mobile stuff that requires extremely low power. So Samsung has established a methodology with PowerPro where they have a 3-stage methodology. So they call it the multi-stage power reduction methodology. First, they use PowerPro's early power checking profiles, and all IP owners in the organization are required to make sure that the IPs go through this early power checking methodology and that they meet the power quality criteria. So they have defined key performance indicators for power based on the various metrics that PowerPro reports. So they say, okay, your gating percentage could not be less than this, your clock gating enable efficiency could not be less than that, and you don't have any redundant constant ICGs in your code, for example. You should not be having any flops that have stability that's wasting cycles, or it's have any of the inputs that are not observable at the output, but you're still not gating them. So these kinds of KPIs or key power indicators for power, they have decided by using the metrics that PowerPro offers. And all IPs have to go through this and qualify the criteria. In case they do not, they need to be fixed. Then on the second side, after performing this early stage functional and structural checking, they also do power estimation and optimization. So they run average power analysis, time-based power analysis, and then they try to run, identify the different workloads which are good for, have regular toggle profiles, and they think these are places where we think the average power is higher than we expected it to be, and they run power optimization. So they use the automatic and guided both kinds of power optimization and factor in the changes into the code. And then, this is run on a weekly basis. So Samsung has been able to successfully run power optimization, power estimation, and early power checking offered by PowerPro, and integrate that into a methodology that's mandatory for all IP designers to use. So that was my presentation. Thank you all for your time. And now I'm open for questions.